Alrighty, here we are. We are going to be moving on now formally into Module 4, proportions and rates and proportionality and so on. So what I need you to do is make sure you've got your textbook available and make sure you have your calculator available. So if you need to pause the video at any point, do so that you've got all the tools you need. And we're going to zippity-doo-dah and start to get going. All right? Here we go. So the first thing that we're going to do is talk a little bit about what rates and unit rates are, because you'll see here when you look at the top of the introduction or the first page to Mod 4, this first lesson is on unit rates. We did a little bit of this in Savvy Shopper. Actually, we did a lot of it in Savvy Shopper. So I just want to reiterate what it is we're talking about when we mean rates in math. Let's see. One of the things that maybe you've heard more familiar is talking about like your heart rate. And there you're calculating or thinking about how many heartbeats you have over a certain amount of time. And we watch that when you're exercising to make sure you're staying in a certain zone so you're not pushing yourself too hard and getting yourself or putting yourself at risk for something. So here's what we mean by a rate. A rate is a ratio, which means fraction, or basically it just means that you've got two numbers that you're comparing to each other, okay? Two numbers. A rate means there are two numbers that have different units, like heart rate or heartbeats per minute, or heartbeats, number of heartbeats every 15 seconds. You know, we also think of, if you go to shop for a car, you're often thinking about the mileage rate and what is that like. So if you have a car that's getting maybe 25 miles per 1 gallon or 35 miles per gallon, or you get one of those nice smart cars or something where you can get 50, 60, 70 miles per gallon, there's another rate, different units, heartbeats per minute, miles per hour, and so on. Now, when you were calculating all of those things in Savvy Shopper, that's when we were talking about using unit rates. You're calculating and dividing those two numbers, okay, whether it's heartbeats per minute, miles per gallon, or miles per hour, I should say, or you were figuring out how much it costs per ounce, something like that. There, the denominator is a 1, and that's what we're going to focus on today. So let's see what's going on. Here's our first situation. We've got two people hiking, and Jeff is hiking about a half a mile every 15 minutes. It says Lisa is hiking about a third of a mile every 10 minutes. So we're asking ourselves, well, what is each rate in miles per hour, so that we have some consistency there? And then who's faster? So let's think about this, because this is kind of awkward numbers and things. So I want to think about this in a little different way. All right, so here's Jeff, half a mile every 15 minutes. I don't know if it helps you to think of a clock this way and start thinking like every 15 minutes is when you would get to the 3 or the 6 or the 9 and 12, like that. So 15 minutes is really a fourth of an hour. And then you'd have another 15 minutes would be right here. And then another 15 minutes is there, another 15 minutes there. So you kind of think of it that way. He's going a half a mile here, and then in the next 15 minutes, he'll go another half mile. Here he goes a half mile in the next 15 minutes, and another half mile there. Which, if then we take all those distances and add them up, half, 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 that gives me 2 miles. In a total of 60 minutes, which is the same as 1 hour. Okay, 2 miles in 1 hour, or per 1 hour. Now, some people might like to think of it a little differently, so let me just draw it a little differently for a second. Okay, so if I think, all right, so here here's my timeline, okay? And I'm going to say this is 15 minutes, like this. Some people like to think of it in terms of that's a fourth of an hour, something like that. And then he went a half a mile. And then add on another chunk of 15 minutes or a fourth of an hour, and he went a half a mile. And then another 15 minutes or a fourth of an hour, and that's half a mile. And then the chunk of a mile. Regardless, you get the same answer. It's just kind of figuring out what model works best for you, okay? But here's his rate, 2 miles in 1 hour. Okay, that's Jeff's rate. Let's talk about Lisa. Lisa is walking a third of a mile every 10 minutes. Oh, gross. Those numbers are kind of nasty. So if you like thinking about this as a clock, all right, then I could draw something like that over here. Here's a clock every 10 minutes. Okay, now I'm going to draw this clock knowing full well that maybe this might not be the best visual for some of you. Boy, that's not very accurate. 10 minutes, 10 minutes, 10 minutes. Okay, because every 10 minutes it'd be about, it'd go like to the 2 on the hand and a 4, and then down at the 6, there'd be 30 minutes. 10 minutes, 10 minutes, 10 minutes. Okay, and then another 10 minutes, and another 10 minutes, 30, 40, 50. All right, there's your full hour. We're going a third of a mile each time. 1/3. Third. 1/3. That's right now 3/3 of a mile, or 1 whole mile. 1/3. 1/3. 1/3. There's another mile. Hey, so in the course of 1 hour, she has gone a total of 2 miles. What? They're really the same? Does that even make sense? Huh. Maybe if you are more of a person that likes to think of this in terms of like a long bar, 10 minutes, if I want to figure out basically every 10-minute chunk. So I have a total of 6 of those 10-minute chunks to make the hour. There's 10 minutes, there's 10 minutes, there's 10 minutes, there's 10 minutes. Okay. And then you're thinking 1/3 of a mile, 1/3 of a mile, 1/3 of a mile, 1/3 of a mile, so on, and so on. Okay. Boom. You still end up with 2 minutes, or I'm sorry, 2 miles in the course of 1 hour. So really, these guys are walking at exactly the same rate of speed, which sounds kind of crazy to me, but it's true. So here's what I want you to do. Grab your textbook. Let's open up to page 117, because actually, this is exactly what we just started talking about. How are we going to find and use unit rates? And this is the first thing we did. So here's what they did. I kind of like that clock visual. They did it in a bar like this with this data. So here's Jeff, okay? And in a fourth of an hour, or in other words, this is 15 minutes. If you'd rather think of it this way, 15 minutes. Here's another 15 minutes. Here's another 15 minutes, and so on. And then you counted it up. Here's what we ended up with. So I'm not even answering this first question there. I'm crossing that out. But he hiked 2 miles in 1 hour. Now it said complete this table for Jeff's hike. Well, he went a half mile here, and then he went another half a mile here, which if we're talking about a total here and we start adding, add another mile or another half mile there, that gives me 1. Then I'll have 1.5. Then we have 2. Now hold on. Now after 2 whole hours, he should go twice as far, or 4 miles. All right, now let's look at this same idea for Lisa, okay? This is where Lisa was going every 10 minutes, 10 minutes, 10 minutes, 10 minutes. And what happened with her? Every 10 minutes, she travels a third of a mile. And so if we start adding all of those thirds up, we just discovered she went 2 miles. Sorry, this is kind of not the best writing utensil on my screen here today. So for her, for every 1/6 of an hour, or in other words, this is 10 minutes, and now another 10 minutes puts her at 20 minutes. They're using the fraction of an hour. Here's another 10 minutes that'll put me at 30 minutes, half hour. Then they're going to jump right away to 1 hour, 2 hour, but work with me here. A third of a mile, another third of a mile, add those together, there's 2/3. Add another third of a mile, that's 3/3. 3/3 is exactly equal to 1. Now, if I go right away to the 1 hour mark, I'm at 2 miles. And then if I double it, I'm at 4. Turns out Jeff and Lisa here are actually traveling at the exact same speed or the exact same rate. So even though it looked very different, they end up being exactly the same. It said, how did you find Jeff's distance for 3/4 of an hour? So basically we just added 3. He was going half a mile, so we added 1/2 plus 1/2 plus another 1/2. Who walks further? One. They have the same rate. Now, it'd be nice to be able to draw a picture every time, but sometimes, frankly, it's just not convenient. So sometimes what we do is kind of yield to the good old calculator to help do our work for us, okay? And it's really helpful to make sure we're finding the unit rate, meaning we're getting a fraction over 1, because then we can do some comparing. So take a look at this next example. If you go 60 miles in 2 hours, if you basically either get that in simplest form where 1's the denominator, or just take 60 divided by 2, that's 30, or 30 over 1. That is a unit rate because the denominator at hour is an hour, okay? We'll talk more about complex fractions as we approach this. So let's take a look at this example here where Angela is repainting her kitchen, okay? So she's remodeling, she wants to repaint. She's estimating that she paints about 55 square feet every half hour. How many square feet does she paint in 1 hour? Well, you could think of it kind of in a model like we were doing before. So here's my square feet. I'm going to put that on top. And then down below, I'm thinking time or hours. So I'm thinking, well, at a half hour, she painted 55 square feet. And that means I should move that down a little bit so you can see. And then in a full hour, at 1 hour, I'd add another one on there and I'd get 110. Or you could just simply take this 55 square feet per half hour and grab your calculator and just divide. Because really, that's what we've got going on here. So let me grab that fine and fabulous calculator that we can find on my webpage. And while I'm doing that, you go ahead and practice on your calculator and take 55 divided by 1/2. And you will see, shazam, it's 110. Once you divide like that, is 110 divided by 1 or over 1 now. That's your unit rate. So Angela is figuring that she can paint at a speed or a rate of 110 square feet in 1 hour. There you go. So let's try doing some more. And my calculator's taking forever here, so I apologize. And then I grabbed the wrong thing, so I'm like, get this up one way or the other. Sorry, it's taken so long. All right, so as that is getting worked up a little bit, good grief, that's taken way too long. All right, you get the idea, I hope, okay? Turn the page to 119. Let's see what we got on this one. If Paige mows a sixth of an acre in 1/4 of an hour, how many acres is Paige going to mow in 1 hour? So here's what I want you to think. This sentence is telling you acres per hour. Set up a fraction. Acres over hours. Now, 1/6 of an acre, put that in your numerator. 1/4 of an hour, that's your denominator. Math-wise, you're being asked to take 1/6 divided by 1/4. 1/6 divided by 1/4 ends up being 1/6 times 4/1. You should get something like 2/3. And you have to label this with both of these, acres per hour. Or as a decimal, that's 0.6 repeating. Number 4, Gretchen uses 3 ounces of pasta to make 3/4 of a serving of pasta. How many ounces per serving? So we've got 3 ounces. So write down, we have 3 ounces per serving. But I'm making only 3/4 of a serving. Okay? What we want to do is divide this so that we can calculate how much is this for 1 serving. So this math says take 3 and divide it by 3/4. Shazam. And when you do that, you should get, I believe, 4 ounces per serving. So you can write per or use a fraction bar to write out that. Okay? Alrighty. They've stepped through another example on this page, but basically what I want you to do is let's just zippity-doo-dah to this page with the guided practice problems that you have, which should be over here on page 120. Ooh, but before we get there, so let's take a little detour up here at the top where it's talking about this tank. This tank is filling at a rate of 3/4 a gallon for every 2/3 minute. And then you have another tank that's filling at 5/8 of a gallon per half minute. Which one is filling faster? Oofda. So here's tank number 1. 3/4 gallon in per 2/3 of a minute. All right, grab your calculator and do that division. 3/4 divided by 2/3. While you're doing that, I'm going to do it by hand. 3/4 divided by 2/3 means 3/4 times 3/2. That's 9/8. Okay, 9/8. 9/8 of a gallon per minute. Okay, second one. The second one is filling at 5/8 of a gallon in a half a minute. So let's look at the second tank. 5/8 gallon per 1/2 minute. Well, when I do that, and I'm doing this by hand, 5/8 divided by 1/2, that means 5/8 times 2. When I do that, I get 10/8, which is automatically bigger than 9/8. If you put it in simplest form, it's 5/4. Okay, but this ends up being 10/8 gallons per minute. All right, which means which tank is filling faster? The second one. There you go. Cool. So here's what I want you to do. now that you've gotten those ones done, let's go ahead and have you start working on page 120. Do all the rest of these ones in the guided practice. Do the next page, page 121. That's going through problem number 12. Let me hop over and look at the next page quick. Yeah, I'll have you go right through 13, okay? There's your assignment. Use your calculator. Write down those labels and make sure you write per minute or per hour or whatever it is. Make sure you have both labels in there. Good luck, and may the force be with you.